7, hi 7BM3, welcome to this week's maths video. I'm getting into the swing of making these and I hope they're useful for you and they help you with your maths challenges. Now this week our focus is fractions again, but we're taking that a little bit further and we're going to be looking at subtracting fractions and multiplying fractions. It's not as complicated as some of us think it is. I really want you to try and remember to watch this video so that you can see what tasks I'm guiding you to. I don't want you to do all the tasks on the sheets this week. I just want you to try and look at the ones that I'm going to encourage you to try. So, as always, we start with the maths in Mrs. B's life. So here we go. Are you ready? So, maths in my life this week is to do with food. That's always the exciting bit. We often make shortbread in our house. Brilliant recipe for Scottish shortbread here. But this week we wanted to make extra because we were giving it to various people in our street as a little pick-me-up. So we wanted to make 1.5 times the amount that was on the recipe in the book. So what do? How would you work out how to change these amounts to become 1.5 times the original amount? So have a think. What are you going to do? And let's now have a look at how we did it. We did it as a family together. So if I want 200 grams of flour, if I want 1.5 times, I want 200 grams because that's the one, but I want half of that again. So half of 200 is going to be 100, and then I'm going to end up with 300 grams of flour. That's going to be my new amount. I then come to the butter and I want 120 grams. So I want 1.5 times. So 1 is going to be the amount that's there already. And a half again is going to be half of that amount, which is 60 grams. Then 120 plus 60 is going to be 180 grams of butter. And lastly, the sugar, not much sugar in shortbread, lots of butter, delicious. We want 50 grams, but we want 1.5. So 50 is the 1/2 of that is going to be 25. That's going to give me 75 grams of butter. So my final recipe for 1.5 times is going to be 300 grams of flour, 180 grams of butter and 75 grams of sugar. So that was the maths. Go baking, try the recipe. Don't forget the sprinkling of sugar at the end. Good luck. This week's tasks, guys, then are to do again with fractions. So we are this time subtracting fractions. Now there's lots of the things that you learned and did last week that you're going to have to remember for this week. So the first thing we're going to think about is the denominator and the numerator. Now when we were adding fractions last week, if the denominator was the same, this is subtraction with the same denominator. If the denominator is the same, we know the answer is going to have that as the denominator in your answer. So 5/8, take away 2/8. We simply do it as a very simple calculation. 5 take away 2. 5 take away 2 is 3/8. So that's going to be our answer. Now, can I simplify this? Can I divide it by 2? No. Can I divide both the numerator and the denominator by 2? 3? No. Can I divide them both by 5? No. That's the simplest I can present that fraction, that answer. Let's try another one. We've got 4/8, take away 2/8. Again, the answer, the denominator, is going to have 8, it's 8ths. 4, take away 2, it's a simple calculation, is going to give me 2/8. Can I simplify that? Can I divide the top and the bottom by 2? Yes, my cameraman is nodding. Yes, I can. So 2 divided by 2 gives me 1. 8 divided by 2 gives me 4. So that is my final answer and that's been simplified. So have a go at these ones. It's all about simplifying the final answer. Have a go. Okay, so for task 2 then, 7BM3, we are still focusing on subtraction, but this time the denominators are not the same. So what are we going to do here? Well, let's take this first example. 1/5, take away 1/10. We can't do that without making them both have the same denominator. So my first question to you is, let's look and see if we can use this larger denominator. You have a smaller one and a bigger one. We want to see if we can make them both into the bigger one. Does the smaller one go into the bigger one? And yes, it does. 5 goes into 10. 10 divided by 5, there are 2 of them. So I'm going to rewrite this as something, we want to get them both to tenths. So what have I got done to the 5 to get it to 10? I've multiplied it by 2. So that means I have to multiply the top by 2. So I get 2/10. That makes it really easy for me. 2/10, take away 1/10, gives me 1/10. That's my final answer. I can't simplify that. I have got 1 on the top. That's my final answer. Let's try it with a different one. 5/7, take away 23/35. Now that looks horrible. We can make this a bit simpler. Let's have a look. Does the smaller denominator go into the larger denominator? Well, yes, it does. So 7 times 5 is 35. There are 5 7s in 35. So let's rewrite this. We're going to have something over 35. Take away 23/35. So I've multiplied the 7 by 5 to get it to 35. That means I've got to multiply the top by 5. 5 times 5 is 25. I've now got 25, take away 23/35. Well, that makes it easier. My answer is going to be in 35ths. The top, 25 take away 23 gives me 2. So my answer is going to be 2/35. Can I simplify that? I can't. That's my final answer. Better not write on the wall. That's my final answer for that question. This is all about recognising, can I find a common denominator using those that are in the question. Give them a go. Good luck. Okay, 7BM3, we're on to task 3. This is where it's starting to get a little bit tricky now. This is also subtraction, also with different denominators, but this is where we can't find one of these denominators that we can use for the other one, basically. So we have to change both denominators into a common denominator. This is really requiring knowledge of your times tables. So let's have a go at the first one and we'll try and apply a strategy. So we've got to find a common multiple of these numbers. We have to find a number that is in both the 3 times table and the 7 times table. That's what we're trying to find out. So rather than try to do all of that in my head, let's go to the 3 times table and I'm going to write it down the side. 3, 6, 9, 12, 15, 18, 21, 24. I'm going to stop there. That might be enough. I now need to write down the 7 multiples of 7. So I've got 7, 14, 21, and already I'm seeing, well, there's 21 in both of these times tables. So 21 is the lowest common multiple of these numbers. So I now know that my new denominator, my common denominator for both of these is going to be 21. Now, what I've now got to work out is what do I multiply the tops by? So what have I multiplied 3 by to get it to 21? Well, it's 7 of them. I've multiplied it by 7. So that's multiplied by 7. So as we did last week, if I'm multiplying the bottom by 7, what have I got to do to the top? Multiply it by 7. So 2 times 7 is going to be 14. I've then got to look at this one. Now this is not the same. This is not by 7. This was what have I done to 7 to get it to 21? Well, I know that there's 3 of them. I've multiplied by 3. So if I've multiplied the bottom by 3, I have to multiply the top by 3. So 1 times 3 is going to be 3. So 14 21sts, take away 3 21sts. The answer is going to be in 21sts. 14 take away 3 is going to be 11. Now, I can't simplify that, so that is my final answer. Let's try another one. It's all about times tables. 1/4 take away 1/5. So I've got to find a denominator that is suitable for both of these. So I have to find a common multiple. So as before, we're going to start with 4, 4, 8, 12, 16, 20. I'm going to stop and see if that's enough. I can always add on more later. Then I've got 5, 10, 15, 20. Oh, and look, here I have my common multiple. So I know my answer is going to be in 20ths. So what have I done to 4 to get it to 20? Well, I've multiplied it by 5. So 4 times 5 gets me to 20. What do I have to do to the top? 1 times 5 is going to give me 5 20ths. But remember, I can't multiply this by 5 because it's got its own story. So what have I done to get 5 to 20? I've multiplied it by 4. I have to then multiply the top by 4 because there were 4 5s in 20. So 4 times 1 is 4. 5 20ths, take away 4 20ths is going to be 1 20th. And that's my final answer because I can't simplify it. So these jottings and calculations are going to be really, really important. Once again, you can do this. Go for it. Okay, so you have tasks 1, 2, 3 and 4 on the sheet 3, the first sheet you've been given for fractions. I only want you to focus on tasks 1, 2 and 3. If you want to try task 4, you can, but that's a little bit of an extension. So I'm not going over that in this video because I don't really want you to focus hugely on that. I'm now going to take you to tasks 1 and 2 of the final sheet in this week's pack. I don't want you to try tasks 3 and 4, just tasks 1 and 2. Now I'm dealing with these both together because they're very, very similar in your approach to deal with these. So we're moving on to multiplication now. We've dealt with subtraction, this is now multiplication. Okay, so I just want you to look at tasks 1 and 2. So have a look, these are quite easy. With multiplication, it doesn't matter what the denominators are, we can just plough on and start multiplying numerators and denominators. So let's have a look at this first one. When we multiply, all we need to do, multiply the top, get an answer, multiply the bottom, answer, hey presto, done. So 3 times 1 gives me 3, 4 times 3 gives me 12. That's the answer. But is it? Does it need simplified? Can we simplify that fraction? Well, as we said, bit of a cheat way of finding out. You could look at common factors, but what we can look at here is, can I divide them both by 2? And I can do that one, but not that one. Can I divide them both by 3? Yes, I can. 3 divided by 3 is 1. 12 divided by 3 is 4. That's my simplified final answer. So here is our final answer for this question. Now this is the only other tricky ones that you may come across in these first 2 tasks that I want you to look at. 3 times 3/5. Now you do not multiply the top and the bottom by 3. We have to turn them both into fractions. So what's 3 as a fraction? Well, 3 as a fraction is, it can't be 1 over 3. That would be a third. That's not even a whole 1. It's got to be 3 divided by 1. 3 over 1. So any whole number over 1 is itself as a fraction. Okay, so 3 as a fraction is 3 over 1 because 3 divided by 1 gives us 3. So that's that as a fraction. That is true for any whole number, any integer. Then we're multiplying it by 3/5. So we can now do what we did up here. 3 times 3 is 9. 1 times 5 is 5. Now we're facing a bit of a problem here because this is now an improper fraction. We want to give the answer, if we want it as an improper fraction, that's fine. But if we want to give this as a mixed number answer, we've got to work out what that is. So 9/5, if I had 9/5 of pizza, I would have more than one pizza. So I know that 5/5 is 1. So 5/5 is 1. So I know in this case the answer is going to be 1 and something else. So if I've used 5/5 to make the 1, how many fifths have I got left? Well, 9 take away 5 gives me 4/5. That's what I've got left. So the answer is 1 and 4/5. These are equivalent fractions, but this would be my final answer. Please try tasks 1 and 2. You do not have to try tasks 3 and 4. Good luck, year 7. You've got this in the bag. If all else fails, do fractions with chocolate or biscuits and have a little nibble of a quarter or a third or a fifth or a 27th. Good luck. I'll see you next week. So as always, we're going to finish and we're going to look at how the kittens are doing. So they are doing really, really well. But as you can see, we've got one of them that they were all very similar in their mass at the start, but they're really branching out now. They're finding not only individual personalities, but they're also becoming quite individual in terms of their size and also the type of fur they've got. So we've got this guy up here. We called him Biggie at the moment without a name. He really is much bigger than the littlest one. This one in the middle has become the absolute fluffiest. But you can see they're now moving apart, but all are really healthy because what we're interested in is they are all ascending on this graph. They're all increasing in their mass, which is really important. Now you can see that we missed a couple of days of data recording. We've just plotted nothing in those places. We had no data, so there's no data to plot. So it's goodbye from me, and it's goodbye from these little guys. This one here is Biggie, who's trying to escape. Lots of energy. Yeah, we see you. And these two little ones here, they're fast asleep. Having a good old sleep. Goodbye, guys. See you next week. Bye-bye. Bye-bye.